Hey everyone, so in this video we're going to be solving systems by substitution. It's our first algebraic method to solve. In the last video we solved by graphing, where we were able to visualize the intersection point, which is the solution to my system. But what if my solution is decimal values or it's off my graph? How can we figure out what the solution is if the lines aren't easy to graph? All right, the method we're going to use today is called substitution. Now, what does substitution mean? So in the kitchen, we substitute ingredients in a recipe all the time. So let's say we don't have a certain ingredient, we can find an equivalent ingredient to substitute in its place. And that's what we're going to do here. We're going to substitute one of the equations into the other so that we can solve for one variable at a time. Because we don't know how to solve for two variables at the same time. Instead, we're going to get this down to an equation in just one variable. So like in example 1a, we got our system y equals 2x and 4x minus y equals 6. So according to the first equation, y equals 2x. Y and 2x are the same exact thing. So every time I see a y in the second equation, I can plug in 2x. I can substitute in 2x. Okay, so this is going to look like 4x minus, but instead of y, I can substitute in 2x. Everything else stays the same, but instead of y, I'm substituting 2x. So I got 4x minus 2x equals 6. If I solve this now, it's down to one variable. I can solve for just x. 2x equals 6, so x is equal to 3. Now from here, we've got the x coordinate. Now we need to figure out the y. We need to figure out both parts in order to get the entire solution. So I'm going to plug that 3 back into either equation. It doesn't matter, the top one or the bottom one. We're going to plug it back in order for me to solve for y. So like in the first equation, we get y equals 2x. But instead of x, I can plug in 3 because I just figured out that x equals 3. 2 times 3 is 6, so y equals 6. Or I could do the second equation, 4x, but instead of x, I'm going to plug in 3 minus y equals 6. So I get 12 minus y equals 6. Subtract 12 from both sides, I get negative y equals negative 6. Divide both sides by negative 1, I'll get y equals 6. Again, hopefully you see, it does not matter which equation you plug that first variable value into. When you solve for the second, you should get the same exact thing because the solution which is 3, 6, needs to work for both of my equations. That's the whole idea of a solution, is that it satisfies both equations in the system. All right, if I were to graph these two lines, they would intersect at 3, 6. All right, what about in B though? In B, I got 2x plus 5y equals negative 5 and x plus 3y equals 3. I don't have a variable by itself ready for me to substitute. But hopefully you notice in the second equation, the x is really close to being by itself. All right, so I'm just going to rewrite the second equation to get the x by itself. And in order to do that, I just need to subtract 3y over to the other side. Now the x is by itself. So I can take this 3 minus 3y, and since it equals x, I can plug this in for x in my first equation. So I've got 2 times 3 minus 3y. Okay, because I'm taking 3 minus 3y and I'm substituting it in for x. Make sure you've got your parentheses around it because that whole thing is being multiplied by 2. And then the rest of the equation stays the same. Plus 5y equals negative 5. I'm going to highlight this part for you. Make it a different color so that way you see that that's what we substituted in. Okay, now our equation is just dealing with y's. We can solve this. So distribute the 2. So I'll get 6 minus 6y plus 5y equals negative 5. Combine like terms. So negative 6y plus 5y is negative y. Subtract 6 from both sides, so I'll get negative y equals negative 11. Divide by negative 1, y is going to equal 11. All right, so we got one of the variables. We know y equals 11. Now we need to plug it back into either the top equation or the bottom equation in order to solve for x. So like if I plug it into the top, I'm going to get 2x plus 5, but instead of y, I'm going to plug in 11, because that's what we just solved for, equals negative 5. So I get 2x plus 55 equals negative 5. 2x equals negative 60. Or x equals negative 30. Okay? And to double check my work, I'm going to plug it into the bottom equation. X plus 3, but instead of y, plug in 11 equals 3. So x plus 33 equals 3. X equals negative 30. You should get the same exact answer. If you don't, that means your y value was wrong. The first variable you solved for was wrong. So you got to go back because it has to work for both equations. The solution here, x coordinate, then y coordinate, so negative 30, 11. There's the solution to this system. Okay? So, what about in part C? Y minus 2x equals 3 and 6x minus 3y equals 4. Is there a variable that is by itself or that I can easily get by itself? Yes. I can get this top equation. I can get the y by itself. I'm just going to add 2x to both sides. Okay? So now I can take this 3 plus 2x and substitute it in every time I see a y in the second equation. So I'll get 6x minus 3. Instead of y, I'm going to plug in 3 plus 2x equals 4. Make sure you got your parentheses because we've got that whole thing is being multiplied by negative 3. Okay? From here, distribute. We're just going to do what we know to do because of our solving steps. Now we just got to get the x by itself. All right, so I distribute. I combine like terms, but notice what happens. We got 6x minus 6x. That cancels out. 6x minus 6x, that goes away, and I'm left with negative 9 equals 4. Negative 9 equals 4. The variables canceled out. So think back to when we talked about solving equations. We're left with negative 9 equals 4. Is that a true statement? No, that's a false statement. So what does that mean? What's the solution here? Well, there is no solution. Since what we're left with is a false statement, the variables canceled out and we're left with a false statement, that's no solution. Which, if you remember, that means that these lines don't intersect. So these are parallel lines. If I got these equations into slope-intercept form, you would notice that they have the same slope, but different y-intercepts. Okay? So that would be no solution, as if you have a false statement. So remember, kind of a sidebar here, if you're left with a false statement, that's no solution. If you're left with a true statement, like if your variables cancel out and you're left with 2 equals 2, that's always true. That's infinitely many solutions. That would be meaning that they would be the same exact line. They would be lying right on top of each other because whatever works for the first equation works for the second. They would be the same exact line if you're left with a true statement. Therefore, you would have infinitely many solutions. Okay? So make sure you remember these. If your variables cancel out, you're looking at whether you have a true statement or a false statement. Okay? What about a word problem? How's that going to work? So like for our last example, tickets to the school play cost $5 for adults, $5 for students, $7 for adults. You made a total of $1,450 and sold 50 more student tickets than adult tickets. How many of each ticket did you sell? All right, well, we got a couple things going on here. We've got an equation that we can set up that deals with the money, and an equation that we can set up due to this statement right here. We sold 50 more student tickets than adult tickets. All right, so our two equations, we've got S equals the number of student tickets and A equals the number of adult tickets. Now the equation with the money, I'll highlight that in a different color. $5 for students, $7 for adults. We made $1,450. Okay, so the equation of that line is going to look like I take $5 per the number of student tickets that I bought, plus $7 times the amount of adult tickets that I bought or sold. And if I take the amount from the students and I take the amount of money from the adults and I add them together, I'll get the total amount. Okay? So this is the equation that deals with the money. But we're also given that we sold 50 more student tickets than adult tickets. All right? So we got to translate that into an equation as well. We sold 50 more student tickets than adult tickets. So think about it like, use some specific examples. If I sold 10 adult tickets, how many student tickets did I sell? 60. I add 50 to that 10. If I sold 22 adult tickets, I sold 50 more student tickets, so I would have sold 72 student tickets. So if I sold A amount of adult tickets, what do I have to do to that A what do I have to do to the number of adult tickets in order to get the number of student tickets? I need to add 50 to it, and that'll equal the number of student tickets. Okay, so we got our system here. We've got two different equations in two different variables. Now we just need to solve it. In order to solve, we've got the S by itself. So I'm going to substitute in the first equation, I'm going to substitute in A plus 50 for S. Okay? And then we can solve for A. Distribute. So we get 5A plus 250 plus 7A equals 1450. So I get 12A equals, use my calculator for quick. It's late, I don't want to do mental math. 1200. So A equals 100. Okay? So the number of adult tickets is 100. All right, the number of student tickets, we just got to add 50 to that. So the number of adult tickets is 100. The number of student tickets is 50 more than that, which is 150. And we can check our answer by plugging it into the first equation. 5 times the number of student tickets, which is 150, plus 7 times the number of adult tickets, which is 100. What is that going to give me? It gives me 1450. That's how we know it's right. Okay? So this is our final answer. So a big thing here is just being able to write the two equations from the word problem, especially being able to translate sentences or phrases like this. Sold 50 more student tickets than adult tickets. Making sure your variables are in the right place. So do what I did. Think about some specific situations. If you sold 10 adult tickets, you add 50 to that to get student tickets. So if you sold A amount of adult tickets, A plus 50 equals S. Think about specifics and then work your way to get to the general equation of A plus 50 equals S. Okay? So that is solving by substitution. just some general math examples and then and then an application problem. If you have any questions, let me know. Make sure you get those practice problems done. Have a good one.